Hello guys, today I got a little tutorial here. It is for HUE app that is used with this controller. It is called SP110E, and I want to just highlight some differences as opposed to, for example, DuoCo Strip. This is just a Bluetooth controller for LED strips like this. Now I'm going to get into the close-ups in a bit, but I want to quickly show you the benefits of using something like LED HUE. So the biggest difference between these two controllers is that this is for controlling pixels. This is for controlling LED strips, and they come in segments. So you can see 1, 2, 3 in a row. So there's 6 SMDs, LEDs in total. This has got segments, each SMD LED. So each individual one can be cut and be used separately. And another example of another pixel strip, you can see the density, and you can see that there's much fewer in a row. So what's cool about these pixel strips is that you can actually set animations to have different colors on different LEDs at one single time. So see what it's doing at the moment is going in a rainbow at one single time. So I got 3 props here, and they're all using this pixel strip controller, which is again SP110E. And you can see I got little gems here, and they're animating, they're like strobing. Now say I wanted to use this LED strip, which is obviously segmented into 3 per row, and there's 6 pixels in total. Obviously it would not fit in there, would it? So we are quite limited. It wouldn't fit there. It might fit there, but we would have problems. Another really cool thing about these pixel strip and their controllers is the efficiency. So in this prop, this is called the Demon Spider Sword from Devil May Cry. It actually has 5 pixels inserted in here. And I remember I'd done a little test to see how long would these batteries last. So I used Sony NP-FW50. So I wanted to see how long it would take until the battery dies. With the controller set to what it's doing right now, so it's kind of strobing like in and out, like it's almost breathing. And it would not turn off for around 36 hours or maybe 40, so the efficiency is incredible. So to compare the pixel strip with its controller against the LED pixel segments, set of 6, with the LED HUE controller, although we didn't test the exact amount of SMDs, LEDs, as opposed to this, which has 5 LEDs in total, the Buster Sword in total had 24, 1 per each material side. So material on one side, material on the other side, that's 12. The second material on one side, and then the other side equals 24. But the Buster Sword's battery died within around maybe 2 hours. So although it wasn't exactly 1-to-1 SMD ratio, you could tell that the efficiency for this is much, much greater. So say you guys buy this SP110E, and say you buy a pixel strip. This one is called SK6812. They have 50 by 50 SMD LEDs, 5mm that way and 5mm that way. I also have other pixels. These are called WS2812. This also has 5mm by 5mm SMD LEDs, and this is another SK6812. But the pixels here are 3.5mm that way and 3.5mm that way. You can see the bottom side of these have a little bit of yellow tint. That is because that is a warm white LED as well. So the SMDs here have a red, green and blue diode, and they mix that together to get any color you want. But these also has a single warm white. If you want to get your whites on this pixel, you have to mix red, green and blue. Whilst on this one, you just have the single diode individually, so it doesn't have to mix red, green and blue together. The reason you might prefer a natural white LED rather than a mixed RGB is because when you mix 3 of them together, the white color doesn't look very natural, and it also uses all 3 diodes together. Whilst if you use just a single one diode, it will be actually used more efficiently because it's not mixing obviously the 3 different colors together. And of course the white will look much more natural. What's confusing about these packages is the connections that they come with. So if you have a look at this strip, we have this, and you can see there is 2 sets of white and red cables. They're just connected in parallel, so you could just chain the connection if you need to. I just actually ignore them and I just cut the ends off because these plugs, they don't go inside one another anyway. But connection wise, it's actually really straightforward. You have a ground, which is labeled G. You have a voltage, which is labeled plus 5V, and then you have a DI, which is just the data. And if you look at the controller, it has those labels there as well. G and D I know stands for ground, VCC is the voltage, and DAT is the data. So that's the only things we need. A really important thing that you may note, you see it says DC 5 to 24 volts. Now that is rated for the controller that is inside here. It is not talking about pixel strip itself. So say you buy a pixel strip that says it's 5 volts, and you use 24 volts or 12 volts, it would probably blow this up. I did do this myself before and it did blow the strip, so it may just go to waste. However, if you use a buck converter and set it to a limit for 5 volts, you could use 12 volts because the buck converter would limit it 5 volts if you set it to that. So I'm actually just going to cut the end off. And then spread these apart. Now you guys may not want to do this, but just to make it simpler, I just pulled the green wire out. You know, I thought it'd be more appropriate to have this lighting neutral. So strip the ends off. I use just little nail scissors. Another really important thing about these pixels is that they have a current flow direction. So you can see there's an arrow there. So the power can't start from this side going that way. So you will need to start connecting it from here where you see the arrow flows and just follow that direction. So what I'm doing now is just I'm cutting the wires a little bit shorter so they don't get in the way. And then I add a bit of solder to the exposed wire. And then I actually solder it on to the same terminals as I mentioned before. I mean, there's labels on these connection points anyway, so it makes it... Okay, that's good enough for now. You can see the arrows pointing at 5 volts, so we can use this. Here we go. And this is what's happening the first time we plug it in. You can see we've got some function. So this is how it's going to look like when it's properly connected. So there's only really two things for connection wise. The direction of the current, and that we connect ground, data and voltage to the corresponding terminals. And of course the correct voltage of the pixel strip, which is 5 volts, and that is set onto my DC power supply. So as you can see, it's pretty straightforward. Ground, CLK, which I don't know what it is, data, voltage, and that's the input source, negative, positive. So let's start off with Android. I've got an iPhone here as well, so we're going to do that in a bit. But let's start off Android. So go into your Play Store, search LED HUE, and then you see at the top, the rating is pretty poor actually, 3.3 stars, and it's by Split Apps. Tap on it and install it. Click on open once it's installed. Right, so this is very important. Make sure that the app actually picks up your device. Allow it. If it has trouble locating it, make sure to also turn on locations. So here we have see location. See, it requires it. No locations access. Device location for all apps is turned off and may not be able to locate your device if it's lost. See what I mean? So this warning comes up. So turn on location. Double check that in your settings. You've got the location on, and you see Bluetooth is on as well. Wi-Fi, let's turn Wi-Fi off. Let's see what happens. Mobile data, I don't think you need. Let's turn them off. Okay, so go back into the app, and there's just a little pull down to refresh. And you see the little circle spinning at the top. That means it's refreshing the list. And now you see we've got a bunch of connections here. So obviously in front of me you can see I have a wide range of selections here, and some of these have already been set up. However, we're going to start on with the one we just actually set up here, so this one here. And by default, it will look like this. SP110E. You see that's the 4th one in a row. So let's tap on SP110E. You can see that there's a check mark at the top left now. And at the bottom, you can see there's a rollout here, and that is for your pixel strip driver. And we know that is an SK6812, so let's find that. And you see as you scroll through them, it changes what happens to them. So we know that this is SK6812, which is this one, and you can see it's working fine. You can also see there's a secondary one, SK6812RGBW. That is if we had the 4th diode that had just a single white, but we know it doesn't, so it just has the 3 diodes, red, green, and blue. So let's find it, SK6812. And on the left is the actual pin sequence that the diodes have been soldered together. Say you selected red and it appears as blue, only then would we modify the sequence. And at the bottom you have total pixels 600. And that just means that there's an infinite amount of pixels, and anything you select will apply to all pixels basically. Unless obviously you're working with more than 600 pixels. But for now, let's just click on enter, let's see what happens. And here we have the default settings. And if we scroll through, you can see that this is changing. So let's click on red. We've got green, so that's wrong. Then let's tap on green. We get red. And let's click on blue. Okay, so blue is correct. So the green appears as red and the red appears as green. So all we just need to switch is red with green. So go back We still got the same MAC address selected at the top, you can see that. So we know that the blue is correct. So B should be on the right side. Yep, so it should be this one. Enter. And let's click on red. Let's click on green. Green is correct. Red is correct. Blue is correct. So all of them are correct. So now we've got the correct driver selected and we have the correct pin sequence. You can see one of the sliders is actually blanked out, which is the very bottom one, and that would be for the white diode if you did have it, but we don't have it here, so we can't slide it. The top slider is the intensity of the light. You can see it's adjusting it. We'll go to the very little, slide it off to the very bottom and it'll turn off. The middle slider doesn't do anything. Why? Because that is the speed of the animation, and we can access the animations with these left and right arrows, you see? Okay, I'm actually going to leave this and I'm going to go into this because this is a more realistic scenario. Now probably you may ask yourself, how the hell do we identify what is what when we have so many of these selections? Now as you can see, some of these have been renamed already. So you can see I've got Katana version 1, Katana V2, White V2, Katana V1. Now this is a really cool thing actually. You can tap and hold on say SP110E and you see rename appears. So let's click on rename. If we delete all the characters, it says should less than 10 letters. So obviously you got to be within 10 characters. So let's say powerful E. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we try to type more, obviously we can't. So let's just tap on OK and refresh it. You can see that it has been renamed. And what's really cool is that when you rename it, this setting is actually stored in the actual Bluetooth controller. It doesn't get saved in a mobile phone, but in an actual device. I know that this is Black Katana version 2, so tap on Black V2, enter it, change it to green, maximum light. So let me show you the animations. So if we scroll through, we've got the rainbow, another kind of rainbow, but much more prominent. And you see the middle slider, we can actually slide it now. That looks pretty cool. And if you really like it, you see there's a heart icon at the top, you can tap on it and it will save it. I like this one. Okay, so let's save that. Let's just save that. Okay, so say we have free save now. Tap and hold the heart and then you can see we are limited to selecting only those 3 that we hearted. And then if you want to get out of the selection, just tap on outside of those arrows. So would that be here? Anywhere outside. And you can see it lets us select all the other presets again. And if you want to just slide through the hue slider, you can just slide this and it cycles through all the colors. So this katana has 96 LEDs for the blade, 98 I believe in this text area as well. What we can actually do, that's really cool with this app, is we can actually change it to limit it to how many pixels it actually uses. So go back and you see at the bottom it says total pixels. Tap there and then you can change it to say 96. Press OK. And you see, all of them turned off. Let's go in between. Let's go 1, 10. Okay. See, some of them turned on. So that is the point of the total pixel count. So you limit it. 1 through 4. Yep. And now all of them are turned back on. So at the bottom you have these circular colors. You can see it's DIY color and then regu color. Regu color obviously stands for regular color and these are preset and you can't change these. However, if you click on one of the colors in the DIY color and then you adjust the DIY slider, you can see that the DIY color icon changes in the selection that you change in this hue slider and it will stay that way. So say I want to save this color, it will stay there. Tap on another DIY color and it will stay there. Also, if you tap on the number area where you see number 3, it'll go auto mode. So that just means it'll just cycle through the presets. Before I move on to the iPhone, I want to show you a quick limitation that you need to be aware of. Say you have a battery like I do connected into this strip of 134 pixels. This is Sony NP-FW50. If you increase the power to something very high, watch what happens. See? It starts to disconnect and the controller starts to reset itself. Now this is because we're using so many pixels and we are so limited by the amount of wattage that the battery can output. So basically the battery can't keep up. And now if we want to reconnect to reduce the lighting output, we try to refresh. Now it's there, white V2. But if we try to connect, it's not going to be able to, because this keeps on powering off and powering back on. So the only solution right now would be to remove the battery. So it's no longer connected, and then connect the DC charger that can output more amperage and in turn more watts. Again, make sure that the voltage is set to the correct setting. If you have a buck converter that's limiting the voltage, then you're fine. Plug it in, and you see that we've got power and it's on. And if we refresh it, then we've got white V2, and then I can reduce the power. So it's a matter of knowing how much wattage that the battery can use, and if that does happen, then you know it's either the battery or the controller that is resetting. So you just need to introduce more power, maybe using a different power source, and then you can reduce the power output on your mobile phone, and then you can use the battery again. Also, if you want to see the notes from the developers of the apps, you can click on this icon in the very top right. It's a little file document, and it will show you the notes from the developers on what does what. Okay, so let's install the same app. We go to the App Store, search LED HUE, search. This one is under Utilities. Tap on it, and here you can see it's actually by a different company, Shenzhen Spur LL Optoelectronic. By looking through the screenshots, it's the exact same app. The ratings here are even worse, 2.7 stars. Click on Get. Once it's installed, click on Open. And you can see instantly that the names have been already remembered from what I already renamed it. Oh yeah, we renamed this one, so let's turn it on and let's refresh it. See if our powerful me is here as well, which we actually just done in this session. And you can see it is there. So let's select Katana V1, and you can see the same settings still appear, GRB, SK6812, and total pixels is 40, which is what I had previously set. And if we try to adjust, so I believe it's this one. Yep, everything's the same, adjusts. Let's try animations. Animations are working good. Say I want to connect to the same Bluetooth controller on another phone. So let's find it here as well. Katana V1. Ah, you see what happened? Connection failed because I'm already connected. So you have to kill the app for it to show up in the other one. So you see Katana V1 underneath that. Connect to it. And you can see total pixels 40, so it's the same one that I had previously connected. Enter it. Red, green, blue. So I kill the app on this phone. And let's refresh the list here. And there we go, Katana 1. And connect it. Everything is the same here. So let's talk about the downsides of SP110E and LED HUE app. You can't individually change the pixel one by one. I initially really wanted to do that for the arduino sword because we have separate gems here. It would have been really cool to have separate colors. And a few other apps actually can connect to the same controller, SP110E, but none of them could actually change each LED individually. So the only route would be to actually get an Arduino and program it yourself. But I really prefer the idea of just buying an all-in-one package controller, which you can instantly connect to your mobile phone. You don't need any extra modules that have Bluetooth and pre-coded. Everything is all done and ready in one package. You just have to install the app and do basically everything I said in this video. So it's just really straightforward if you just want to get down into the fun part of the electronics. Another downside is you can't connect to all of these Bluetooth controllers at one time. Say you wanted to control all these 4 swords and set them all to red. You would have to enter each device individually and change the color there. Not too big of a deal, but say you are filming a scene and want to use all these swords and you want to change them all together at once, it would be much more convenient. So this is a teardown of the DuoCo Strip controller. You can see this one has infrared connector as well as Bluetooth, but I don't like the infrared anyway because you need direct line of sight with this little sensor. And this infrared receiver, you can actually control it with this little remote. So I got little tweezers here. You see the 4 pins here? I like to clip just to the side of it. So have a look. There we go. And you see it starts prying here. And continue going. Yeah. Be very careful if you're going to push, don't push that tip into your hand because that would hurt. The circuitry is actually on the flat side, so as long as you're doing it side to side like that, you shouldn't actually damage anything inside there. Then switch to the other side and repeat, and it's gonna start separating pretty easily. And we'll try that, yeah. Or just maybe insert it and then just twist it. Nope, not yet. You need more. You need to cut it more. Okay, get this side. Actually, before you cut like that, check that the board is on the other side. So if we slightly twist it, aha, you can see that the board was on this side, so I would damage this. So I'm gonna cut this side off instead. Or just twist it slightly. Because the plastic is pretty squishy actually, it's not very hard plastics. And then just continue cutting. Basically I just wanted to make some room so I could cut easier. There we go. You might want to use some pliers maybe for twisting. You can see we start to reveal the board. Do the other side. Now the reason I'm showing you this is because the box is much larger than the actual chip itself. The chip is rather small and it's low profile, so you could actually use it for slim applications. And what I want to show you now is further disassembly. So say I want to get rid of this and this, so you could actually solder directly onto the chipboard. Make sure not to cut the pins, because if you do, you risk of ripping off the solder joint itself. So do not cut the pin, you're just going to cut the plastics off. And the reason I'm cutting off the plastics is so that we can get the soldering iron on the individual joints. And you see I'm just cutting in between each joint, each pin. And the top slightly. Because trust me, I've done this before quite a few times. So I accidentally pulled away the solder joint, and then what I'm forced with is to solder onto the side. So what I like to do to get these all off easily is I put more solder on each joint. That way it's much easier to heat them up all together as one. Okay, so let's try it. There you go, we've got one pin off. And if you're struggling, make a further cut to make sure the plastic is separated. There we go, we've got 2 pins off, 3 pins off, 1 more pin. There we go, all of them are off now. Once you see, I broke one off, but this one isn't actually connected to anything. But this is the 4 that we want the most. And it has the labels there as well. So voltage, data, and ground, that's all we need. And for the power input, same again, I like to cut off from the sides. And cut more at the top side rather than closer to the chipboard. Oh. Oh, see that one flying? You need to be very careful so it doesn't fly in your face. Because there's quite a big chance that it could fly in your face. So you need to be very careful. And again, I'm going to put quite a bit of solder. So I'm just going to heat it up. And once it heats up, I'm just going to use these mini pliers just to pull it away. I think what I'm going to do is hold it like that, and then gently push it with the soldering iron down into the chipboard. At the same time, you've got to make sure you're not touching any other components on the board. You don't want to desolder something by accident. There we go. Same thing here, more solder. And push it away. There we go. And in a backup scenario, say you do pull one of the solder joints off, you have the other side to work with as well, which is corresponding to the same connection points on both sides. So voltage, data, ground, positive, negative. I think that about wraps up the video. So if you enjoyed the video, please give it a like. If you have any questions, do let me know in the comments and I'll try to respond to most of them. Just make sure you obviously watch the video because I go through as many things as I think is needed. If you want to see more props, more swords, building them, tutorials, 3D files, do feel free to subscribe, guys, leave a comment, give it a like, and maybe share it on social media if you want to see more. Take care, guys. Thank you for watching. Peace.